Thank you. My name is Brittany Vanderwerf. I'm Communication and Outreach Manager at New Mexico EPSCoR. New Mexico EPSCoR is part of a larger NSF ecosystem that has a mission to enhance the research competitiveness of targeted jurisdictions like New Mexico. I'll be supporting these rockstar women today, along with my partner in EPSCoR-related crime, Mr. Dustin Allen, who will be working behind the scenes to make sure everything runs smoothly. And if you have questions at any point, this is going to be about an hour long webinar or workshop webinar session. So everybody knows. If you have questions at any point, just unmute yourself. We'd like to have a dialogue. So just feel free to unmute yourself. But we do ask you remain muted when possible if you're joining us from a loud environment. Okay. And also there will be a recording and a transcript of this webinar session that will be made available on our website and elsewhere online. So pay attention and look for that. We'll send out details after the webinar. Now I'm going to turn it over to our honored presenters and stop sharing and let them take over.
Risa, do you want to go ahead and share?
Okay, I was looking where I can unmute myself.
Okay, and thank you. So I want to welcome everyone also. I am Lori. I am former director of the New Mexico Cybersecurity of Excellence. Jessica Trujillo-Torres is on with us. She is the coordinator for the Center of Excellence, and she will be working very soon with the new director. Nathan Fisk has been hired and will be starting next month as the new director. He's already agreed to help with this project. And so when I talk about the director of NMCCOE, that will be Nathan Fisk. And you'll see announcements about his starting in the center in the coming month. But the other people I want to introduce, Risa, do you want to turn your camera on if you can? Raisa Islam is still with us. She is a graduate student. She's a PhD student that's about to finish. And she has been instrumental in getting this project up and going. Noah Fry also worked with us for a long time. He was an undergraduate who graduated in December. And the two of them have done most of the work, let me just be honest, on developing this large language model system for enhancing research collaboration. So that's what this is all about. It's part of the EPSCoR project, which had 3 pillars. One was infrastructure for research. 2 was enhancing professional development and collaboration opportunities. And number 3 was the administrative piece that the EPSCoR main office does essentially with just a few people with this huge collaboration system. And so the pilot project that I proposed was to cross over those first 2 components of EPSCoR to really help us all find collaborators in our own institutions and then across the state to enhance our research productivity and to be able to do more interesting research with better collaboration. For that, Risa and Noah, as I said, did the majority of the actual work of building this system. And then the system administrators at NMCCOE, working with Jessica, have done support for it. They run the servers for it, and have been involved whenever we've had network problems or whatever. So we don't currently have the URL for the statewide system. We're waiting to hear back from the lead system administrator on what that URL is going to be. And once we have that, we will have the EPSCoR office reach out to everyone with what that URL is. But today, Risa is going to take you through the operation of the LLM and how you can use this collaboration discovery tool. Risa, take it away.
Hello, good morning, everyone, and thank you for being here today. My name is Raisa Islam. I'm working with Dr. Lori Librock at New Mexico Tech, and we call our project the Research LLM. The title of today's talk is From Documents to Discovery, and as the name suggests, we are set out to do exactly the same thing. So I will talk more about the problem and how we are trying to solve that in a bit. First, okay, here is the agenda for today's talk. So Dr. Librock already introduced the team, NMCCOE and EPSCoR. Next, I will be talking about the in-house LLM or IHLLM, as we call it. Then we will talk about how participating institutions can participate in two ways. They can run their own in-house LLM or just contribute documents to the statewide instance. And then we will show how in-house research LLM works. And finally, Jess will be talking about how NMCCOE will be support everyone on this project. So the problem. What problem we are trying to solve in our research project? The problem is who else is working on this. So in any research ecosystem, the knowledge that should connect people is fragmented. It lives inside published papers, technical reports, proposals, and documents that are spread across departments and institutions. Finding related work or the right collaborator means manually reviewing all those papers, and then this process is really slow because we have to do it manually, and sometimes it might be incomplete as well, and it does not scale. So the problem is sharpest in newer, fast-moving research areas where the informal network is have not formed yet, and there is no obvious person where we can reach out and ask who is working on this field or area and how can we collaborate with them. Our objective is to transform the scattered documents into structured, queryable knowledge so that discovery and collaboration becomes easier. So how do we approach to solve this problem? Our answer is a research discovery LLM. At its core, it's a retrieval augmented language model that indexes published research and lets anyone find potential collaborators by topic and expertise. The system comes into two tiers. The first is the in-house LLM or IHLLM. It runs locally at an institution, indexes the published papers of that institution, and answers questions privately. The second one is statewide LLM. For our state, it's New Mexico LLM. This is an aggregated instance hosted by NMCCOE that combines contributions from participating institutions. The statewide layer is what makes cross-institutional discovery possible that we might not have known otherwise.
So I want to comment here before you change slides, Raisa, that notice that we said we're talking about published papers. This originally we had a discussion about whether unpublished works and whether restricted access works could be part of this. But because of the federal requirements on export controls, we decided to not do that. So we're intentionally not including things that could potentially result in an export control violation. We're only using the documents that have been published each institution could make other decisions, but we have not implemented the system to divide those access controls by role, specifically because we didn't want the possibility of exposure for either anything classified, proprietary, or export controlled. So that's just a comment on decisions that were made in discussions with our Vice President of Research, and Dr. Lika Kulin. And it was important to us to have that discussion with you all so that you know there's reasoning behind that. Go ahead, Raisa.
So now I will explain how the system works. Under the surface, this is a pipeline that turns raw PDF files into retrieval-ready knowledge, and we have the stages demonstrated in here. So it begins with discovery. In the system, we input the name and email addresses of researchers who are working on the institution, and then based on that information we start paper download based on that the automatic paper download pipeline is started. Sorry. So when we start the automatic paper download, it tries to find all the papers online, and if we cannot access some papers publicly, then we create a list of that, and then a separate email is sent to each researcher asking if they can upload their papers in a Google Drive folder. So we have our own email service system for this, and when we send out the email, we create a very specific Google Drive folder for that author only, and we also give them the list of the papers that we were not able to download, and also the guideline how to upload the papers. So we will be discussing more about that soon in another slide. And on the background, when we download the papers, we start on metadata extraction, like titles, authors, affiliations, dates when the paper was published, abstract of the paper, and keywords. That metadata is normalized against a validated JSON schema, and then we write that into Postgres database. And finally, the curated metadata and document is fed into the large language model for training. And after that, the users can ask questions, and our LLM should be able to answer their questions. On the technology side, the service is built on Fast API. Then we have used a RAG pipeline, sentence transformer embeddings, and an Ollama hosted model. So how it works. This slide shows how the pieces fit together across the state. Each participating institution, say institution A, institution B, and others, they can implement their own in-house research LLM and then connect to the statewide research LLM. Otherwise, if some institution decides that they do not want to implement their own in-house research LLM, they can just upload their papers in the statewide version, and then statewide research LLM will be processing their papers, and the users will be able to ask questions about that institution as well. So how the local in-house LLM works. how do you make the local in-house LLM work? So first you have to get the code from GitLab. I will share the links in a slide later. And then you have to set up the code according to your university. There will be a quick start guide for that too. And the collection process. This is a check. Sorry. The collection process happens in two ways. First one is the automated download pipeline, where we download the papers online via search engine, and when we cannot download some paper, we ask the faculties, and then after that we extract information and train our LLM. So here is how we can set up the in-house LLM for any institution. This is a checklist so that you can have a manageable list of items to update and change to your own specification. First, we have front end, and here we need to change 11 files. 13 actually, because in components page we have 3 files. Next up, we also need to update the credentials, and then backend also. We have secrets folder in the backend. We have environment file, and then many other. Let's start the project. Let's start with front end. In front end, we will go to source, and then we will go to api.js. In here, we can see that we have base URL, which contains the URL for New Mexico Tech. We need to change it in here. And then next in index.js, we have, okay, not index.js. This one we have public index.html. In here, we have the logo. Right now, the logo contains NMCCOA's logo, so we will need to change that. And then we have another logo in somewhere in here. There's component styles logo in here. So we will need to change this as well. We have components auth login. In here, it says connect to an empty single sign-on. You should change that. And after that, we have layout alt header. Here, so here the title says NMT Research LLM. You should change the words and use your institutional name. Same goes for back header. We have NMT Research LLM in here, and then landing header NMT Research LLM. You should change those as well. Styles.main.css. In style.css, we have used NMT's color scheme. So if you want, you can change the color scheme as per your institution. So this is for front end. Next, we have credentials. It's inside the config folder. We have 2 files, credentials.json and token.json. Credential.json is the file that is downloaded from Google Cloud Console after configuring OAuth 2 for the application. And token.json is the file. This file is created after the first credential.json file successfully. A successful Google authentication flow. It stores the authorization tokens used by the application to maintain access to the Google Drive API.
Raisa, I think the video
We
stopped.
are using a basic command shown in. Let me check. It was playing on my end, so I couldn't say.
The audio stopped on our end.
The audio stop is the example. Next app. I don't know, how do I go back?
No, it's back.
Oh, okay. So should I play from which point you didn't get the audio?
Maybe go back like a minute.
In a minute. The credentials?
Maybe not a full minute. That I think you were doing logo stuff. I think that should work.
Okay. Is the email formatting. sp.crt, this generated file is used to sign and certify communications to the service provider. And then we have sp key. This generated key file is used to fulfill identity requirements for the service provider. You can generate service provider key pair using a basic command shown in this example. Next up, we have environment file. Here, the environment file. I will not show our .env file for security purposes. Here is an example. You can see what variables we need to set from here. We need to set the authentication secret, service provider public certificate path, SP private key path, SP sign authentication request, and then we have to assign ITP metadata URL, ITP metadata path, SP metadata path. These three are required for SSO connection. And after that, we have email connection credentials. First one is email backend. Second one is the email host, where you will be hosting your email service, then email server port, if you are using TLS or not, email host user, email host password. And then finally, the default role of the user. So the default role is set to user. Inside the backend file, we have, where is it? Auth config file. So here We have front-end origin, API origin. You need to change these two and set to your localhost server. Next up, we have auto download. Or auto download. So in here as well, we have default from email, which is basically a no reply email. So when we send some notification email, it is sent from the no reply email. And then we have a default admin email. So if someone wants to contact us, they can use this email address. Next, we have parent folder ID. So I was going to talk about it later, but since we are here, the parent folder ID is for the Google Drive folder, where we will be giving access to the other researchers where they can upload their research files. So this is just the folder ID of that drive. And inside this drive, we will be creating subdirectories. And then we have email services. So here we have a function called send generic email. It has everything according to NMT's policy and what we are trying to send. We have send email. This is also how we want to do it. So you should want to change the lines in here in the generic email and notification email. Up next, we have doc handler. In doc handler, same to the previous file, we have default from email, default admin email. Next up, we have helper. In helper, we have Google Drive services. So in here, we have to set up the config directory. So this is basically the folder path where the credentials are. So in our case, we already showed that the credentials are inside the config file. So we are just saying config. You can name it anything else as well. Next, we have institution name.json. So this is a JSON file containing a list of names that your institution is popularly known as. So for our case, New Mexico Tech is also known as the NMTech, New Mexico Institution of Mining and Technology. So what other variations you have, you can just put it in here. And then this file is used in two other files. So we are using this in auto download. Here we are reading from JSON, and it just copies everything from institution name JSON. Also, we use it in detail extraction. Here. Next, we have main.py. So here you might want to change the title. It says EPSCoR LLM API. If you want to change the name, the description, and then middleware. The middleware is research LLM local cybersecurity .nmt.edu. You should be able to change it to your institutional URL. So that's pretty much it for front-end, back-end, and configuration. Next is the instruction about running the application. So in order to run the application, once you have all of the configured all of this configured, you will use Podman Compose app build, Podman Compose app build if you are using Podman. Otherwise, it can be Docker Compose. We have used Podman because it adds more security. The YML file is configured. This initiates the starts of all volumes and rebuilds with any backend updates. So if you update the backend files, this will update with those changes. App will simply bring back up the last run occurrence of the application without any new updates. If you simply use Compose app, you have to use build to build with new changes. Then Compose down, we have Compose down in here. It will exit the process gracefully, but then Compose down -v exits and clears all volumes. This is helpful if you want to check and tweak databases and models. This does get rid of everything in the database, so keep that in mind. Podman system reset, so we have it in here. Podman system reset helps clear what Docker dependency bloats within the application. This is just stored image files, stored volume files from past runs, but sometimes it's helpful to reset this. It is also recommended to reset before your final run whenever you are intending to finally run the application. Next, we have a guideline for the users, how they can create an account in Research LLM, how to log in, and how they can chat.
Now, there's a simple landing page with a simple introduction to the app, as long as simple ways to use it, about who we are, about our mission, and then some helpful links at the bottom in the footer. These links take you to the contact page, where you can input your email, subject, and message, and we will get back to you very shortly. The FAQ page, which holds information about the application. Right now, this is basic introduction to the application, the backend, and how things are working, as well as how you can use the app to find collaborators. This will update as we receive more questions and more feedback, but this is used right now as just like a introductory guide. The Help Center is yet another contact page where you input your email, subject, and message, but this is dedicated a little bit more towards help and support so that we know that you need aid in how to use the application. Legally, we have the privacy policy, the terms of service, and the cookie policy. You can read these, and by logging into the application, you agree to these implicitly. So we'll log in, and by logging in, we utilize single sign-on. Single sign-on through normally your university or institution. This means that I, as a New Mexico Tech person, am able to log in with my New Mexico Tech credentials for safe, secure, efficient, and very fast login. So this will be set up with your university or institution's credentials, and you'll be able to log in with those. So I will log in now. And this takes us to the basic dashboard page. At the dashboard page, we see a chat page. The chat page is rather simple, asking that the user simply input a message to the text field with buttons to send and buttons in the header to check your account and log out of the application. To find papers, we can simply ask the chatbot, what papers do you have on machine learning? So I'll take that, send this back over, but not without first saying hello to the application. So hi there. What papers do you have on machine learning? And now we see a nice list of papers along with their authors. So yeah, let's say that we believe that paper 3 may have some information that we need. So let's say that we believe that this is proper, this is good. Let's start finding more information about these authors, right? Can you get from the authors in paper 3? And now we see papers that match our authors, provide contact. So this is William Ampama. And this allows us to find more papers from them. So let's say that we're particularly interested now in paper 5. So now we will ask the application to provide a basic abstract of the paper. And this will help us gain knowledge about what is inside. So we noticed that William Ampama previously has fields inside of New Mexico Tech. So let's see, what papers do you have from authors at New Mexico Tech? And we go through, we find the authors that work at New Mexico Tech, in this case, Anthony Morgan, for this paper, and the paper. Now we could ask more information about this, or etc. The user account page, however, can be used to further guide this prompt. We'll see that here. We'll go to the account page, and this is the basic information about you, the user. So you can see that during the onboarding step, I have logged in with my display name. This is the email that was brought back from SSO, the time zone that was brought back from SSO. I assigned the organization that I am a part of. I also assigned whether or not I want research connections, the areas of research that I work in, and the role inside of the application that I am. This will just show as user for you. You can edit this to state that you want connections for research or not, and keywords to guide the prompt. So by checking this box, you agree that based upon your areas of research, you would like to be contacted in those fields for more research, right? So by clicking this box and stating, my area of research is machine learning, now is a simple landing page. Papers related to reinforcement learning. What we do is we attach the context for
So you have watched how a user can create their accounts and then also chat with the research LLM. Next up, we will see what are the features that an admin can access, how they can upload new papers to enhance the research LLM and other features. This tutorial aims to introduce admin users to their role requirements, as well as detail how the admin users are able to perform those functions within the application. The research LLM is intended to make the system super easy and secure on any system. If at the end of this tutorial you have any question, please contact us using the contact page or by contacting NMCCOE. Application introduction. This application at face value is a RAG-style LLM application built on top of a GEMA 3.4b model. This uses simple embedding cross encoding and adapting models from Hugging Face in order to train documents and be able to pull using queries. Each of these Hugging Face models are trained using the parse documents. This means that each model incorporates each of the information of the file and places each of them on, say, a graph. Similar papers or words are placed closer together, and thus they will be pulled together with similar queries. In this way, whenever a user inputs a prompt, that prompt is embedded using the same encoder that we trained using our data. That way, whenever we take our prompt, we can place it near similar papers using similar wording. So prompts provide similar papers, and this is how RAG works. Admin user privileges and roles. So an admin user is responsible for ensuring the functionality of the application by performing actions that update, delete, and retain the model. They are also responsible for handling the user database, where they will have the sole responsibility for promoting and demoting users to the admin role, as well as deleting users when requested. Admin users are given access to a special version of the chat page that will allow them to enter the admin control page, where they will be given many more options to manipulate the application. So initial login as an admin. Admin privileges are assigned from the university or institution. If you are an admin, congratulations. Now that you have been given admin privileges, you are able to access this admin controls page, where you will be able to make sure that the model is updated and retrained with the most accurate documents from the databases at the most reasonable times. And you can download new PDFs using a CSV file containing the name of researchers and their emails. You can also upload new documents to be used for training, update the user database, and perform the training loop, which is pre-processing and retraining. Other functions of the application, like chatting, the account, logging in, logging out, and checking the footers or anything like that, they work just as normal, just with this added permission. Let's get started with the demo. First off, we need to log in. Here, if we go to the URL, here we will have a login option. If you click on it, you will see another option, sign in to SSO. Here we have landed on admin chat page. Here you can see that we have admin controls option. So if we go there, you can see we have many other options. First, we can check our user account. Here you see I am registered as Raisa Islam. This is my email address. I can edit and then edit the areas of my research. I can choose to be connected or contacted with potential connections for research, or I can opt out. I have both the option, and if I am choosing it, let's save this. Let's go back to dashboard. Now in here we have multiple options. First one is upload new documents for training. In here we can upload a single PDF or a zip file, which will contain multiple other PDFs. Let's see how this works. Here is the interface for uploaded document. If we click on choose a file, we will go. Let's do this. So I have paper one in here. I am choosing this. And then when I click on upload, It will take some time depending on the size of the file. If you are choosing to upload a zip file, it might take longer. Now that I have uploaded the document, let's go back to admin dashboard. After I have uploaded a file, we need to pre-process, and then after pre-processing, we will follow up with retraining model. Next, we have download new PDFs. So this option gives us a automated pipeline that will automatically download research papers given a CSV file containing the name and email addresses of the researchers of your institution. So here we can choose the file. Let's choose it. I have tester group CSV. I will upload this one and then upload. The file has uploaded successfully, and after the file has been uploaded, it will run in the background. It will use that CSV files to automatically download papers, and when it is done with downloading all the papers, it will give me notification in here. So here I have previous notifications where I have automatically downloaded papers, I have retrained model, and you can do many more things. Along with notification, in the notification bell icon, you will also be sent an email. Now here we have handled the database. Here we can see the list of users, purge data, promote a user to admin, demote a admin to a normal user, and delete user account. Let's see our list of users in here. So right now I am the only user. Let's go back to dashboard. Next off, we have set time. Set time allows to set a definite time for retry downloading. So I already mentioned that when we upload a CSV file, it automatically downloads file, but it is possible that when it is trying to download files, it may find some files publicly not accessible. So it will keep a list of those files and then periodically try to again download them. So we have received a notification in here. You can see, let's see. So it says auto download finished. So we can now retrain model. It will also run on the background. Next, we have copy files to drive. It takes input of the input in here is a link of a Google Drive file. So when we put the link and then submit, it will automatically collect all the local files which we have been uploaded using upload new documents, or we have downloaded using download new PDFs, and then it will copy all of them into that specific Google Drive. This feature helps to use all the in-house LLM PDFs to use for training in statewide LLM. We have got another notification. So it says model retraining is also done. Then we have list JSON titles. Here we have the list of files. We can hide JSON titles. Let's go back to the dashboard. So in here, we can just ask questions. Let's say, give me name of a computer and research. So it has given us a list of researchers. Here we can see Dr. Laurie Librock. And then we have the option to log out as well. So in this video, we will see we saw how an admin will manage the in-house LLM. Next, as we mentioned in our automated download pipeline, when we fail to access some paper publicly, we send email to the author of that paper. So in that instruction or in that email, they will receive a list of papers that we were not able to download, and then we will send them a guideline for upload, like what to do and what not to do. So the paper they will upload should be searchable PDFs, and the listed ones, if they want, they can also upload their unpublished work, but we recommend not uploading proprietary work which should not be accessible by other people, because right now we do not have rule-based access. And they should not upload drafts or incomplete manuscripts or presentation files, any file that has sensitive or confidential data or restricted access. And how to upload: in the email, we will send them a Google Drive link, which is dedicated for that specific researcher. No one else can access that drive folder. They should sign in using their institutional email address, and then they can simply drag and drop the PDF file or select to upload file, and they should wait until the file upload is finished. We suggest not to upload duplicate files, and then upload only if there is any already existing files from their previous uploads. We encourage not to delete them, and if they have any issue in the email, we will send them share the contact information of an admin, so they will be able to contact the admin. So how we can contribute documents directly to statewide LLM? So far, we have discussed how to implement in-house LLM, and then in-house LLM, we showed that we have an option where we can copy all our local files just in a click from a Google Drive link. And if we want to, if any institution decides that they do not want to implement their own in-house LLM, they can have one Google Drive folder where they can collect all their searchable PDFs, bundle them, and then we can use that upload document option, and then that way all their research documents will be uploaded in the statewide version. Now, getting admin access, I would request Dr. Laurie Librock to share more information about how someone can get admin access.
So our Vice President of Research has had numerous discussions on this, and the decision's been made that we will ask that you contact the new director at NMCCOE, Nathan Fisk. You can do that through the email address that will be shared at the end, that is nmccoe@nmt.edu. And there you'll ask for admin access to the statewide system. That'll be one person that represents each research institution. And that access should come through your vice president of research or whoever your research lead is. Dr. Fisk will be verifying that person is the correct person through your research office or your institutional leadership. And then he will use that to provide access through the sysadmin team and support at NMCCOE. At the moment, since he doesn't start for about a month, that would be through Jessica Trujillo Torres, and I will help her as needed with that. But Dr. Fisk will be the contact for this system, the lead contact for the system in the long term. Go ahead, Raisa.
So up here we have some important links. So our Git is our code base is hosted in git.cybersecurity.nmt.edu, and the project is named EPSCoR NM RIO-NM. So if you want, you can download the code from here. I believe this should be publicly accessible. But if not, you can contact NMCCOE office, you can contact Jess, and they will be able to help you. And then we have the quick setup guide, the PDF version in this Google Drive link. We have user tutorial for both in-house LLM and statewide LLM. Then we have admin user guide for both for in-house LLM, statewide one. And our NMT research LLM is hosted in this address. It should not be, right now, it should not be able to access publicly, but the statewide one is currently on progress, and when that is done, you should be hearing from EPSCoR or Dr. Lori Librock or Jessica. They might make the announcement. And our YouTube videos are available at this YouTube channel. We call it NM Research Collaborations. So if you go to that channel, you will be able to see the YouTube videos. Yeah, that's pretty much it. If you cannot access any of this, please reach out. Someone might be able to help. I would ask Jessica to say something about NMCCOE, how they might support. Is she here yet?
Yes, she's here.
Okay.
Jess, you want to come on?
Hi, yes. So,
Your video's not on. The camera's covered, I think.
there you go.
There we go.
Okay, yes. So, NMCCOE is here to help Risa with all her projects that she's doing. We are also helping her with the servers here at the center. Like they mentioned, we have our system administrators that are working hard with her and trying to make sure that she keeps everything going smoothly. We're here to help her with onboarding. We're here to help her with traveling. We're here to support her in any way we're able to. And we help a lot with I guess you could say, the background of her project. We're not seen, we're just known.
And in the future, NMCCOE and the new director is going to be the host for the statewide system. So the NMCCOE will be continuing to support that as
Yes.
long as that server is able to do so, which we purchased a server specifically for this, and it's housed in NMCCOE. And therefore, the new director, Nathan Fisk, is going to be the point of contact for that once he starts next month.
Yes, and then once he starts next month, we will also introduce him to everybody and maybe have a short meeting or something so that he could get involved more and he could get a little bit more details on what was going on, and he could ask his questions as needed.
So we look forward to introducing him to everyone. Do you have anything to wrap up, Risa? Does anyone have questions?
And
Hearing
just a
none, I
reminder, if
guess,
you do
Risa?
have
go
questions,
ahead.
just unmute. If you do have questions, just unmute yourself.
Please. Otherwise, I want to thank Risa for all of her work on this project. She's about to graduate and go away and do great things as a new doctor. So thank you very much, Risa. And I guess we'll turn it back to you.
All right, awesome. Once again, thank you to all of our presenters. Thank you, Raisa. Thank you, Dr. Liebrock, and thank you, Jessica. As a reminder, we're going to have a transcript and recording of this on our website and also on YouTube. And we thank you so much for joining us today. Have a great day, and thanks for joining us.
Thank you. Have a good day.
Bye, everyone.